It is said that we know more about the surface of the moon than the ocean floor. We can only guess at what lies at the bottom of the sea: natural resources, precious metals, or maybe the cure for the common cold. So to rectify this lack of knowledge, our intrepid engineer, Jimmy, has decided to become the next Jacques Cousteau and is busy designing a new submersible. He has a concept design, but will it work? Is it safe? Jimmy's submersible is going to be subjected to some pretty intense loads. The pressure at the maximum dive depth is equivalent to 4 African bull elephants standing on every square inch. And then there are the black smokers, hydrothermal vents gushing out water, gas, and minerals at temperatures reaching 400 degrees centigrade. In addition to these normal deep-sea environmental loads, the fact that this is an exploration vehicle means that it should be hardened to withstand impacts both on the ocean floor and on the mothership. Jimmy has roughed out a preliminary design and is looking to use SolidWorks simulation to answer fundamental safety questions about his design, help settle his nervous stomach, and give him the confidence to take his submersible to experience the wonders of the deep. Jimmy's primary concern is the integrity of the pressure hull. He has to make sure it can withstand the immense pressure and high temperatures while working near the mysterious black smokers. To do this, Jimmy looks at the factor of safety. The higher the factor of safety, the safer the design. But this safety comes at a cost, generally the cost of materials. So the desire for a high factor of safety has to be balanced against the material cost and the weight of your design. Jimmy wants his submersible to be safe, just not too safe. After a bit of work, Jimmy is happy that his preliminary design can survive the rigors of the deep. But how many dives can his design safely make? It's a simple step to determine this number by running a fatigue analysis. This type of analysis can take a design through a virtual life test. In this case, we are cycling the thermal and pressure loads that would occur on each dive. With a safe estimated life of over 10,000 dives, Jimmy is confident he can move forward with his design. The design is now evolving fast, and Jimmy has decided to equip his submersible with a large bubble dome. Now his challenge is to safely attach a high-strength acrylic dome to a metal cylinder using bolts and a rubber seal. But how many bolts and what size? Once more, Jimmy turns to the power of simulation to tell him the answer. Combining SolidWorks simulation, configurations, and design studies, Jimmy quickly iterates his design to ensure a watertight seal at the maximum dive depth. With the design coming together nicely, Jimmy is looking to harden the submersible to ensure that it is robust enough to withstand the rough and tumble of offshore deep-sea exploration. One could easily imagine a scenario where the submarine is being recovered in rough seas and is accidentally dropped on the deck or hits against the side of the ship. SolidWorks simulation makes complex drop test and impact analysis available to every designer. Jimmy now has the confidence to finish his design, head for the ocean floor, and maybe find the cure for the common cold. Just like Jimmy, all designers can benefit from an early warning of possible performance or safety issues. Although the simulation of real-world problems might seem daunting at first, SolidWorks simulation gives you the power to solve complex problems without complexity. It also allows you to see how your product will perform during its service life without having to build expensive and time-consuming prototypes. By giving you greater understanding of how your product will perform, SolidWorks simulation gives you the vital information you need to make good engineering and design decisions, making your products better and your customers more satisfied. To find out more about SolidWorks simulation tools, contact your local SolidWorks reseller or explore the site further.